All right, good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unuafi. Today, we want to discuss on the second section of hazardous area awareness. Lately, we discussed about hazardous area awareness. Today, we are going to talk and discuss with regards to hazardous area zone. As you all know, the global demand for electrical equipment and automation device in achieving safe and reliable project execution, it is essential to assess environmental zoning, particularly in reaction to flammable atmosphere, to ensure safety and performance of all equipment and personnel. So therefore, hazardous area zoning is an area subdivided into zones based on the likelihood of occurrence and duration of flammable atmosphere. And this flammable atmosphere is as follows. Subdivided into zone 0. That is a part of a hazardous zone area where a flammable atmosphere continuously present in more than 1,000 hours a year. And I want you to note that in a year, we have 8,760 hours. So in zone 1 is a part of hazardous area where a flammable atmosphere is likely to occur in normal operation more than 10, but less than 1,000 hours a year. Zone 2. Zone 2 is the part of hazardous area where a flammable atmosphere is not likely to occur in normal operation, but even if it occurs, is for a short time and is less than 10 hours a year. And for us to have this clearly, there must be a classification technique. And experience has shown that a certain location may unclassified regardless of the ventilation and rate of occurrence of a flammable gas or vapor liberation from such apparatus. And that is why, for an example, a location where a flammable substance are obtained in a welded closed piping system without valves, flange, or similar device. And what it means is that a location where a flammable substance contained in all welded closed piping system without valve, flange, or similar device, it means that the system is designed as a sealed continuous pipeline without no opening, joint, or mechanical fitting that could be potential source of leakage or source of ignition. And such systems are typically used to minimize the risk of a fire explosive by eliminating the leak component like flange or valves, by reducing the exposure to the air and external ignition source, by ensuring the structural integrity through welding. And this kind of design is often found in hazardous environment where it is paramount, such as a chemical plant, oil refinery, or gas processing facility. For example, imagine a refinery transporting a liquid petroleum gas, known as what? LPG, from a storage tank to a processing unit. To ensure a maximum safety, the pipeline is fully welded from the end to end. There are no valves, no flange, no threaded connection along the route. The system is pressurized and monitored monthly. with access only at the endpoint. This setup ensures that the flammable LPG is completely closed and reducing the chance of leakage or vapor releasing that could ignite it. It is also a similar classification of area as non-hazardous, since the risk of flammable vapor escaping is extremely low. Now, in this classification, we now understand that the extent of hazardous area is the distance in any direction, vertical, horizontal, from the source of release. The point where the flammable atmosphere has been diluted with air to a sufficient low level. For a better understanding, I want you to understand that this refers to an external hazardous zone created by releasing of flammable substance. Specifically, it describes the distance, both vertical, horizontal, from the point of release to the location where the concentration of the flammable vapor has been diluted by air to a level that is no longer considered as hazardous. This concept is critical in hazardous area classification, especially under the standard of IEC 6079/100/10/1, which guide the design of placement of electrical equipment in environment where explosive atmosphere may occur. The key idea is to determine how far this flammable vapor can travel before it become linked to a source of ignition, that is below its lower explosive limit, which is LAE. The distance helps to define the boundaries of zone 0, zone 1, as the case may be, in classification. I want you to understand also that, for example, let's set an example. For example, let's say a natural gas pressure regulator installed out of a leak or at outdoor. Now, if a leak occurs at that regulator, the gas begins to dispense its leakage into the surrounding air. Initially, the concentration near the leak is higher within the flammable range. As the gas mixes with air, the concentration drops. At a certain distance, let's say 1.5 meter horizontal or 0.5 meter vertical, the concentration fall below lower explosive limits. And if you multiply 1.5 meter plus 0.5 meter, the zone around the leak source is considered as hazardous and must be classified according to zone 1. Beyond this point, the atmosphere is sufficient, diluted, and no longer poses a risk of ignition under a normal condition. Hazardous area awareness.